Hello, this is pre-calc lesson 94, graphs of secant and cosecant, graphs of tangent and cotangent. Finally! I know we've been waiting for this forever. I have. So let's talk about secant and cosecant. So secant and cosecant are reciprocals to sine and cosine, okay, which we know that secant is 1 over cosine and cosecant is 1 over sine. They are not continuous. This is because if we think of the domain 1 over cosine, there are areas where cosine is 0. We cannot have 0 in the denominator, so we have an asymptote. We have asymptotes when sine is 0 for for cosecant, and we have asymptotes where cosine is 0 for secant. Okay, so these are the graphs for cosecant and secant. You do need to memorize them, as we did with sine, cosine. Okay, so what we notice here is that 180 and 360 for the graph of cosecant, right? We have asymptotes because sine of 180 and sine of 360 are 0. Okay. Then we also note here, because the sine of 90 is 1, 1 over 1 is 1. The sine of 270 is -1, and 1 over -1 is -1. That's why we get these values here. And then we create these parabolas in between our parameters. There's also really an asymptote at 0 because sine of 0 is 0. Secant, very similar. We have asymptotes at 90 and 270 because that is where cosine is 0. Cosine of 90 and cosine of 270 are 0. And we look here, right? This is similar to the cosine graph where we're going through the y-axis at 1. We're just going up, okay? If you continued it, so if we had -90, that would be the other half there. Okay, now let's look at it. So here, if you can see the difference in colors, black versus red. Black here is the graph of cosecant, red is the graph of sine. So our normal sine graph goes through here, right? And it actually touches everywhere that our cosecant graph is. Same with cosine, right? Cosine goes like this, okay, and the secant is kind of on top here and on bottom here. Okay, that's where we get those values from. All right, now let's do an example. Okay, we want to find the equation of each of these graphs. So let's look at this one on the left here first. Okay, we know automatically that it's going to be a cosecant graph because we have asymptotes at 180 and at 360. Okay, the only difference though is instead of going through 1, we're going through a half, which changes our amplitude. Okay, now let's look over here. Well, actually, one at a time. So this graph over here is y equals 0.5 cosecant of theta. Let's look at this one. We know it's going to be a secant graph because we asymptotes through 90 and 270. Now, if we notice our base here, instead of going through 1, it's going through 10.5. And instead of having 0 here, we have 10, which means we have a vertical shift up to 10 and an amplitude change to 0.5. So we get y equals 10 plus 0.5 secant of theta. Okay, you will be asked to recognize graphs and you will be asked to graph secant and cosecant. So you need to know them really well. Same thing with tangent and cotangent. Okay, tangent is undefined when cosine is 0 because we remember that tangent is sine over cosine, and cotangent is undefined when sine is 0. Okay, so here are our graphs. Y equals tangent of theta, y equals cotangent of theta. Tangent of theta, we have asymptotes at -90, 90 to 70. Okay, and instead of only pointing up or only pointing down, we remember when we talked about tangent is an odd function? This is what it looks like. Okay, it has one endpoint going down, one endpoint going up. Okay, and it goes through 0, 0. It also goes through 180, 0. Because sine of 0 and sine of 180 are 0. Okay, cotangent, very similar. Okay, except it has asymptotes at 180 and 360, and it's going the opposite direction. It also has an asymptote at 0, excuse me, because the sine of 0 is 0, right? So instead of going, starting at the left and going to the right, we start at the, well, we are pointing up first and then we go down. Okay, so let's do an example. Oops. We want to graph y equals -2 times tangent of theta. Now let's make a little side note. Okay, the -2, what's it going to do? So the 2, typically the tangent of 45 we know is 1, right? If we multiply that by 2, we get 2. 2 times 1. Okay, now this negative means that it's going to reflect the graph, so it's going to go in an opposite direction. And the 2 tells us it's going to stretch our graph. Okay, so we end up getting something like this. Okay, now I was bad, so I didn't label my points. Okay, so it's hard to tell that it's elongated, but it is. And we can also see that we still have the same asymptotes, -90, 90, 270. But it looks more like the cotangent graph now because it's been reflected. So it's going up first and then down. So you need to know your cosecant, secant, tangent, and cotangent graphs as well as you know the cosine and sine. That is all for today.